Hey everyone, a while ago we bought a few of the receivers for our ever-growing fleet of cars, and interestingly one of the receivers did not work. We couldn't bind it to our transmitter. The behavior was quite weird because the LED seemed to blink usually as it should, and there was a signal at the output, it just didn't want to bind. So I played around a little bit with it, and I had a programmer that could read the ESquareProm chip here, where I suspected that there may be the unique code used for binding inside. And I took a receiver that was bound already to the transmitter, read the code out from the chip, put it in this receiver here, and it worked fine. So I thought, strange. Did not really analyze what the problem could be, and was happy that it worked. So I used it in the car until we started to drive around and found out that we had extremely limited range. Basically 10 meters away the car stopped responding, and the receiver did not receive a signal. So it became pretty clear that there must be some issue in the antenna path, because it also explains why I couldn't bind the receiver. This particular receiver requires that you bring the transmitter very close. Actually, you almost have to touch the antenna physically before it will even bind when you push the bind button. And since obviously there is a problem with the incoming signal, the incoming signal is too weak for whatever reason that we have not yet identified, the binding procedure fails, even though the receiver is actually working fine in terms of behavior, just that the antenna doesn't work. So let's have a look what we can analyze and whether we can find the problem. The modern 2.4 GHz receiver, they are all very similar in design. Here we have an RF chip. This particular one is from Nordic Semiconductor. It's widely used in a variety of applications like RF remote controls and all kind of stuff. It has quite a good reputation. It's a low-cost chip, but works very well. This one also has a built-in microcontroller. So on this particular board there is only a single chip that does the RF as well as all the logic and the software. We have here, as I said earlier, a small I2C ESquareProm. I2C is a bus that only has a data and a clock line, and ESquareProm means that it's a storage that holds the data even when you power it off. There are a couple of LEDs in here, a green one and a red one, the bind button, all the outputs, so one battery port and the channel 1, 2 and 3. Over here we have the power supply. There is a low voltage regulator that takes the 5 to 6 volt from the BEC and converts it into the 3.3 volt that all the chips nowadays need, with a big coupling capacitor. There seems to be another voltage regulator in here. Not sure exactly what it's for. And then if we look at here, we have the antenna coming in, and here is the path where all the RF filtering takes place and goes into the chip. So since we're suspecting a problem in the antenna path, so from over here down to the chip, let's have a closer look with a microscope and see if we can see anything. So I set up my USB microscope and zoomed into the part of the circuit board where the incoming antenna path is. So you can clearly see the antenna. It goes into some sort of filtering. Disclaimer, I don't really understand much about RF electronics, so I'm not quite sure exactly what all the stuff is, but basically I'm more or less guessing. But there's some filtering. There seems to be some amplifier. This is clearly an active device where there is power here, ground here, a lot of this coupling and an input and an output. You can actually see there's quite a big trace from the antenna path through the whole circuit. After the amplifier there's yet another filter, and then it goes here into some passive components, most likely resistors, capacitors and inductors, and goes into the chip over here. So you can really see there is a kind of a big trace that seems to be the antenna signal. And when we look closely here, there seems to be something missing, as well as over here. So that's certainly an interesting finding, especially this component here. This component over there seems to actually be in parallel, so it's not clear what it is. So let's have a look at the datasheet. Okay, so I looked on the internet and found the schematics using my favorite search engine. And if we look here at the area where the antenna comes in, you can see that there is some input circuitry comprised of inductors and capacitors, and we can certainly match that to the components that we find on the board. Now there is no filtering, there is no amplification like we saw on a receiver, but that doesn't matter because the component is missing is very close to the chip, and that circuitry is in the reference diagram as well. So if we look here, we see that there are two capacitors to ground, and one of them is NA, which means not available, which means it shouldn't be stuffed. So that explains why one of the position is empty. Then we have 3 inductors of 6.8 and 4.7 nanofarad, and capacitors on the input side. So let's zoom into the PCB with the microscope even more, and see if we can find out which of the components is actually missing. Alright, we are zoomed in, and we have here our chip. Here is the component that is missing, and here is another empty slot. Now remember, there were one capacitor in parallel with another one, which was one of the capacitors said is not available. And if you look carefully, you can see that those components are in parallel, and they have here on the edge wire, most likely towards ground. So it's very likely that this is the component that is not needed in this diagram. It's very interesting that they still put it on the board, but yeah, that's what happens sometimes. And then we can see here 1, 2, and 3 components where these 3 inductors were. There is one across the pins, one was towards the voltage where the capacitors are, and the other one was towards the antenna, and that inductor seems to be missing. Here is some two capacitors. Now I assume they are capacitors because from the components themselves you cannot actually see that, simply because of the coloring and how they are aligned. Those 4 components are white. This one is brown, this one is a darker brown, so they seem to be capacitors here and the inductors here. But just to make sure, I will actually off camera take a multimeter and verify that indeed the white components are inductors, which means they should have a very low resistance. If I measure it with the ohm meter, and that this one over here are actually the capacitor, the input capacitor, and it should have a very high impedance. So if you look carefully, you can also see that apparently there was already a chip on there, and it's just somehow came off. Maybe during testing, maybe during transport, it's just very unclear. And the chip in question is indeed an inductor, and it's a 4.7 nanofarad, sorry, a nanohenry. Now that's a very tiny value, and that's only really common in the RF domain. You can still get them easily online. Actually, I was lucky enough to get a few samples from the office from some of my colleagues, which happen to have them in the drawer. They are just a cent item, so they're not really expensive, but yeah, if you need them, you have to buy them, most likely maybe 50 pieces or 100 pieces, but still it's really just a few cents per chip. So even if you have to buy them from Element 14 or RS Components or DigiKey, that's not an issue. So let me get the soldering iron out and put that inductor on. These components are 0402 size, which means they are less than 1 millimeter on their longest side, so they're really tiny, and they're not exactly fun to solder. They're actually already very annoying in terms of hand soldering. They are clearly designed for machine stuff. Let me see if I can solder on camera. If not, then I will let you know. Okay, that wasn't the easiest solder job I've ever done. On the contrary, it was very difficult because there is no space. I had the camera and the microscope in front of me, and all that together didn't help really. But I think I succeeded and got the inductor on. Now we will have to test it. So let's see, I put on a servo, a micro servo. I have a PEC. It's still working. The green LED is on. It's as bound as before. The servo is working. But the trick is, will it bind to the vehicle? And yes, it does. Let's change the vehicle on the receiver. Okay. Different vehicle, the red light is on, and it's green light, and that's a success. So it looks like we have fixed the problem. The missing inductor was the issue. Of course, before I seriously use this receiver now, I will do an extensive range test of a second person to ensure that this is the only problem that this particular receiver had. But it looks very promising. It was about half an hour work, which is not really much. And the cost of the inductor is something like 2 cents. So certainly worth it to try. I hope you like it. I hope you learned something. It's not really hard to diagnose and repair these kind of things. So next time, before you throw stuff away, give it a go. It's very satisfying to get things working. Thank you.